all the units that I've produced in the series so far, I've shared with you a whole lot of activities that you could use in teaching the different topics, either in physics or in chemistry. And then it remains still for you, the teacher, to work out how do you build that activity into your lessons and into your teaching. This unit is going to be a little bit different, because what I'd like to talk with you about is some of the principles of science teaching, or some of the principles of teaching generally, on which one would base the way in which you teach, and therefore the way in which you would plan your lesson. What I've often seen in what people would consider really good teaching often is a class full of learners sitting listening to a teacher who's really very good at explaining different concepts, often with support of equipment and that sort of thing, and students following him or her, and generally being led through the logic of the thing. And as the lesson is being taught, the important points are being noted on the board, and so a set of notes is developed. Some questions are asked of the students, but generally they're fairly low-key questions that center around memory, often repeating what the teachers told them already. And at the end of it all, students will take down those notes and go back and maybe learn them. And that would be considered a successful lesson. But if I look at it, it would be effective to a certain extent, but there's something vitally wrong with such an approach for me, and that is that in such teaching, all the students are passive receivers of somebody else's learning, and they just sitting absorbing all the concepts without being challenged to put it to use, to make it their own, to actually work with it, and so on. And therefore, I think the real learning is frustrated for the students in the process. And so one of the first principles on which I base my teaching is based on the nature of learning. How do children actually learn? And I believe that students need to be actively involved in that learning process and not simply passive receivers. They need to be actively engaged in thinking, talking, working with whatever concepts are being dealt with. And the challenge, therefore, for the teacher is, how do I structure my lesson so that I build that in to it? Let me use two examples from two different units that I've shared with you so far, one chemistry, one physics, to illustrate how I might go about it. The first unit I'd refer to is the one on the teaching of hydrogen bonding, where, if you've seen that unit, I suggest that a way of dealing with hydrogen bonding is through a very simple activity in which one takes a glass, fills it with water to the brim, and right up to the top, and then asks students to predict how many coins can be put into this glass before the water spills over. And they then go through that exercise. Now, if I was the teacher in that exercise there, I would stop at the point where I've shown them how to put the coins into the water, and I'm challenged them with the question, how many coins are required? I'm challenging them to make a prediction. If I've got enough coins, if I've got enough cups, I would get students to work in pairs so that they actually physically go and do the experiment themselves, or they can work in small groups. But the learning now shifts completely. Now the children are much more engaged. I would make them write their prediction down on a piece of paper. In other words, really commit themselves. Don't do the experiment until I can see what you're predicting. I'm forcing children to engage. And they then have got to carry on, do the experiment, observe what's happening, and then interpret that observation. In other words, I'm getting them to collect some data, and from that data interpret and explain what's going on. All of that is demanding of children that they think, that they observe carefully, that they're working with their hands, that they're developing skills, manipulative skills, and so on. And they've got a partner to talk to about it. And in that talking, there's a very important learning process. They're articulating their thoughts. Me as a teacher, I would walk around prodding them with more questions, getting them to think, and so on. And in that way, students become much more engaged in the learning. When the time comes to pull it all together, students will be in a much better position to volunteer answers. They'll feel much more confident because they've been able to test some of their ideas out with their peers. It's much less threatening than trying to venture an answer in a class full of children. And we would tie it all up. At the end of it all, they'll know, well, there are forces between the molecules. We call those forces hydrogen bonds, and that results in surface tension. Perhaps I might get them also to write a short explanation, perhaps supported by a sketch in their notebooks about the activity they've just done. Why would I do that? Because I'm forcing them through writing, in this case over here, to articulate their thinking, to draw a sketch to support that. These are all very important scientific processes that scientists use. It's all valuable learning. It's not just simply the knowledge that they end up with. In that unit, I went on where after the water, we tried the same experiment with paraffin. I guess if I were teaching that lesson, I would simply do that as a demonstration. I wouldn't put kids all the way through another activity using paraffin. I think it would be time consuming, and time is a problem for science teachers. I would get them to do the little exercises that I showed in that unit on detergents and the effect of detergents on surface tension and how detergents work and that sort of thing, because that's really exciting stuff. There was another important element in that unit there, and that was the issue of trying to work with something that's counterintuitive, something where it's going to produce an observation that children aren't expecting at all. There they may have estimated that 3 or 4 coins were needed before you get spillover, and finally they're putting in about the 14th or the 15th before it spills over. It clearly is surprising, and that's exactly what science works on. It's the trying to develop curiosity where things seem to be out of the normal, looking for the explanations why and so on. So all of that would be part of my lesson. And finally, I would end up sending children home with some sort of activity where they've got to try and look for applications of what we've been talking about in the class today at home. Why do I do that? Well, it's again trying to encourage them to apply their knowledge, to look for connections. That's what scientists do. Talk to their families about it, because that's going to bring in an articulation exercise again. It's all part of learning. Coming back the next day, sharing what they'd come up with, and so on. So there's a whole lot of ways in which I would structure my lesson so that it wasn't just a teacher talk, that children were actually actively engaged as well in that lesson. Right, and then the second example that I would refer to is a unit that I gave you on electric circuits and how to teach electricity using a conceptual approach. And in that I used this circuit board that I'd made that uses household electricity, 220 volts. Now in this case over here, this is a teacher demonstration. I haven't got enough of these, I've only made one, so children are not going to be able to do this on their own. So the challenge for me is, how do I still engage them in being active in the learning and following me blindly, maybe thinking about the soccer match last night or something else? Well, in instances like this, what I would do is couple it with a worksheet that I've developed. where each student has got one of these, and there are various circuits that I will work through and set up for them. And before I push the switch to switch the electricity on, I would ask them to predict which one's going to be brighter than the other, or what is they going to see, and to also give a reason. And maybe I'll get them to talk to the person sitting next to them as well. Once they've gone through that process, we'll then flick the magic switch, and they will be able to check whether their prediction was correct or not, and talk to their friend about it where it wasn't right, and try and work out why it is what it is, and so on. So in that way, I'm deliberately brought in something that's going to involve students actively in that learning process. So there are different ways in which you can do it. If you are just demonstrating, you actually aren't able to organize the children, get their hands on the equipment. Anyway, that's the very first teaching principle that I wish to share with you. There will be some other units in which I'll explore others.